We introduced Chat2Layout, interactive 3D furniture layout with a multimodal large language model. Our method designs an agent that enables users to manipulate the 3D layout through both concrete and abstract text instructions. Most importantly, it supports multi-turn conversational user interactions. Our agent system begins by perceiving the requirements provided by the user, along with the indoor scene descriptions and visual captures supplied by the observer from the environment. In the Brain module, the agent translates the user's requirements into a task and breaks it down into a sequence of atomic tasks. It then reasons about the 3D actions required for each atomic task to compile a sequence of 3D actions. All interactions with the multimodal large language model adhere to the vision question paradigm, which encompasses two primary techniques: a visual text prompting technique to aid the agent in reasoning and decision-making, and an offline to online search method to provide the support set for the prompting. These actions are carried out in the Action module, ultimately altering the UI environment. Users can see the updated 3D indoor scene and continue providing new requirements. We propose a grid coverage algorithm for layout plan, as it is challenging for the agent to directly assign cover cells for a large set of furniture. We conduct a local by local placement. We first arrange the three larger items and subsequently position the remaining two smaller ones. Placing very large objects can cover many cells, leading to inaccuracies. Thus, we propose a scale adaptive grid placement. For large items such as a kindergarten plastic mat, we initially place it on a sparse grid to minimize the number of covered cells. We then project it onto a denser grid of the same floor and arrange additional pieces of furniture. For face orientation correction, we initially perform pose alignment using the axis-aligned bounding box and the optimal bounding box. Then we formulate a visual question accompanied by 4 options, allowing the agent to predict the initial face orientation of the furniture. Finally, we engage in a dialogue with the agent to determine the correct orientation, following the visual question paradigm. We propose an offline to online search method to identify the optimal informative support set. Starting with a database of n examples, we categorize them into groups based on their characteristics. Next, we calculate the information entropy for each group and select demonstrations with the top k highest information entropy values from each group. During a user interaction, when given a test input, we initiate a conversation with the agent to determine its group index, then select this group as the final support set for the vision question paradigm. We have developed a user interface that allows users to interact with the 3D environment using text instructions. Our method allows users to add new objects. Our method allows users to remove objects. Our method allows users to rotate or scale objects. Our method allows users to rearrange partial layout. Users can control the viewpoint and lighting for a better visualization. We show more interactive layout generation results. We show diverse layout generation results. Our method also supports multi-room and irregular layout generations. We compare our method with any home, layout GPT, and InstructScene. Our method produces more reasonable layout plans. Thanks for watching.